Hi, my name is Randy, and I am with Project Team 016 for the Campus Explorer app for 310. And today we'll be showing off our app. And so to start, let's start with the Campus Explorer specification and to view the buildings on a map. So we are already displaying a map, base map using Google Maps, and we can see all of the various buildings of UBC all plotted on this map. And so those fulfill the two requirements in the viewings buildings on a map section. Let's move on to the room insights. And so the user needs to select between 0, 1, and 5 rooms. So right now we have 0 rooms selected. So this is the 0 case, and it looks satisfied. And we display our room data on the selected rooms and our relationships on the routes tab. So let's first add a forestry 1001. And so that will show up on the map and it'll clear all the other markers on the map to reduce clutter. So as you can see the short name, which is FSC, the number, which is 1001, the Forest Sciences Center, which is the full name, and then the number of seats it has, and then the location. So let's add another building. So let's add Cheap 101, which is where 310 is this term. And so you can see the map zooms in, and then we have the marker for forestry, and then the marker for cheap. So let's add another 3. Let's go from Cheap to IRC1, which, because this is old data, it'll go to IRC. So it'll go to wood instead of IRC. And then let's add bio 2000. And then let's go from bio all the way to maybe orchard. Great. So now we have 5 rooms as required by the spec. So we have forestry, Cheap, IRC, bio, and orchard. And you can see here the relationships between all the rooms. So you can see the estimated walking time. So like from Cheap to wood is 6 minutes, and then from like Cheap all the way to bio is like 8 minutes because it takes a good while. And so for something like really far, for example, if I wanted to go from Orchard all the way to Iona, which is where Econ is, you can add that to the route, and that's like 20 minutes, right? So that fulfills the accuracy requirement. Okay, great. So that's the basic requirements on the spec complete. Let's move on to our custom user stories. And so one user story that I wanted as a cyclist was a cycling path. So sometimes routes for cycling are different than ones when you walk. And of course, you're faster on a bike. So when we click cycling routes, it'll recalculate the map for cycling. So it'll like take the main roads, for instance, and it produces a more accurate estimate, which is done using the Google Maps API, and we wrap that up using our own API. Okay, great. Let's move on to the search user story. Um, and so for search, you might have already seen, but if we search for something like Woodward, right? If I put an IRC, that doesn't really show up anything because this data is old and the old room codes are wood. So if I search up like instructional resource center, right? It does show up there because we've implemented our fuzzy search. And so, well, this story is actually just for room code. So we can do like wood, we can do like Buchanan, or we can do like DP 101, right? I forgot the M and it still completes. So it's a smarter search that we've done. Okay, great. Let's move on to our walking path. So the walking path is pretty trivial. You've already seen this. So these are the walking paths are already generated here. You can see walking paths with their time estimates. Great. Let's move on to view. This is just straight from the Campus Explorer spec. And so this is, I want, for all the rooms I've selected, I want to view them so I can see their full name and everything. So we can see their names. That meets our acceptance criteria. Great. Okay, let's move on to our code. So we have, so all the network requests have been streamed here in case you have not seen. So let's close out our stuff. Okay, great. Let's look at our integration tests for the front end first. So I decided to use Playwright. So I'm going to run yarn playwright dash UI, I think. Oh no, sorry. Yarn playwright dash test UI. And so this will open up the Playwright testing window, which will search for all the tests. And then when I run them, they will hopefully pass. Great. They all pass, which is exactly to be desired. And to demonstrate the validity of our tests, let's um, let's purposely inject a bug. So let's change localhost 8080, which is where the server is located, to localhost 8081, which is the wrong port. So we're going to inject this bug. It's great. And then I'm going to restart the testing UI. And then I'm going to let this run in the background. Yeah. Okay. It's going to take a little bit because it'll constantly retry. Okay, let's move on to our server code while this is running. So our server code is in source REST as described by the spec. And so we've kind of separated our endpoints into an endpoints for rooms and an endpoint for routes. And so the routing API is quite simple. It defines two post endpoints and then a get endpoint. And then two get endpoints corresponding to those, like with the same path as those post endpoints. And so we just have a helper here, which when it reads the body of the post, and then it goes to our custom route calculator code, which just wraps the Google Maps API and makes a request, forwards the request to the Google Maps API, and then returns it in our schema that we've defined here. And so here, and the interesting thing is that we use like a cache to hold our requests. So that way duplicate requests can just go to the cache instead of recalling the API. And it also makes it more restful because we can return the indices in the API, and then the client will have to use get. So because that was one of the requirements. Let's go to our rooms. So our rooms here is also pretty straightforward, and so we also just define a few endpoints. The most interesting one maybe is probably rooms ID, the one that allows us to search. So we have a query string, and then we have a limit that we take in, and then we have a search function here that we pass into, and then we use this library to perform the fuzzy search that you saw in the UI, and then we apply a limit if it's specified in the parameter. So yeah, so like limit is all of these are optional. Yeah, and then we have the app.ts here, which just starts up the server. And so another interesting thing is all we do in the server is we actually just add the data set. We just do dependency injection. We set up the facade in start, and then we just pass it in. So yeah, that's our app code. Let's look at our tests. So yeah, our tests fail now with the bug. So that shows the validity of our tests, that they actually do capture bugs when we point to when the API is broken. So yeah, that's it for our tests. And I think that's everything for our app.